Today we're going to be working on a C program called Caesar.c, which reads characters from its input and writes the characters to its output, encrypted with a Caesar cipher. Basically, a Caesar cipher is just a shift along the alphabet, so it shifts each letter a certain number of positions in the alphabet. The number of positions to shift will be given to your program as a command line argument. And characters that are not letters should not be encrypted. So things like space or commas, they should not be encrypted, they should just be left the same. And then our program will stop when we reach end of input. So to do this, we want to create a new file, and so I'm going to use gedit to create Caesar.c, C-A-S-A-R.c, and we're going to put an ampersand there to make sure we can still use our terminal. The first thing I want to do is create a header comment. So I'm going to write out basically a little title, encrypting text with a Caesar cipher. Given a shift number, encrypt text with a Caesar cipher. So just a little explanation of what the program does. We also want the program's author, Dean Wonder, and the date 2018-04-17. For this program, we're going to need to hash include two libraries. The first is standard IO, which is the one we usually hash include. And the new one today is standard lib. So this one will include a function called a to I, which we're going to use today. Okay, so let's start by first making our int main function. Instead of putting void in our parameters, we're going to put something else. In this case, we're going to want to accept command line arguments. So because we're doing that, we're going to write int argc and char star argv with square brackets on the end. So these are kind of like two variables that the main function accepts. And this is for accepting command line arguments. So when we run the program, we'll probably type something like /Caesar, but then we can follow that by extra data. So we can include the shift number in this case. So say it's 10. When we type this and run the program, we want the program to be able to access this number, the 10. And we can do that using the argc and the argv variables. So argc, which stands for argument count, is basically the number of arguments given to the program. In this case, when it's run with /Caesar 10, the argc, you might think it's 1, but it's actually 2, because /Caesar counts for the first argument, and then 10 counts for the second argument. Argv is actually an array, and it's an array of char stars, which are basically strings. So now we can, in argv, it contains the strings which were entered in the terminal. So the first index or the 0th index of the array, which will be /Caesar, and then the first index will be the string 10. Keep in mind that this is actually the character 1 followed by the character 0. It's not actually the number. So we're going to need to convert it later on. Okay, so actually the first thing we want to do is check to make sure that the program was run correctly. Because if argc is not equal to 2, then that means that the user who's running the program has forgotten to put a 10 here, or has maybe put 2 numbers or something. And we only want one number after the /Caesar. So if it's not equal to 2, we have a problem. And so we're going to exit the program early by returning 1, which means that we've encountered a problem in our program. But we're also going to print out an error message. So I'm going to use a function called fprintf, which is basically similar to printf, but it can print to std. So we're going to type in our formatted string. We're going to say usage equals %s, and then shift in angled brackets. I'll just put a new line there, and then the thing we're going to put in %s is actually argv0, which argv0 is the kind of the command we use to run the program, but only the first part, the name of the program. So when we print this out, it'll say usage equals /Caesar, or whatever it is, followed by shift. So it's telling the user to input shift. So let's run the program and see this happen. dcc-o Caesar.c. Okay, so we haven't got any compiler errors, that's good. If we type in Caesar and forget to put a command line argument here, we get this little error message, which is good. If we put a command line argument here, it works. If we put two command line arguments here, or we have argc equal to 3, then it doesn't work. We get the error message again. Okay, good. So that's working as intended. I'm just going to add a little comment here telling what we're doing. So I'm just going to say check to make sure, make sure the program was ran correctly. Good. The next thing we want to do is convert the command line argument into an int. Currently, as it stands, argv1, which is the 10, is just a string. So a string of the character 1 followed by the character 0. And so we want to convert it to an int so we can perform kind of mathematical operations on it. So the way we do that is we type int shift, which is where it's going to end up, and we use a to I, which is a function in standard library, and it converts an ASCII, well, the A stands for ASCII, it converts a string to an integer, and we're going to give it argv1. Cool, so now we have our shift. What I'm going to do is just make sure that this works. I'm going to printf the shift. Shift is equal to %d/n shift. Okay, so we can save this program and just test that that code works properly. So I'll compile again, and then we'll run the program. Yep, so shift is equal to 10, so that's working properly. Okay, let's get rid of this printf and continue programming. The next thing we want to do is convert shifts to a range between 0 and 25. Between 0 and 25. So the thing is that the user can enter in any number. They could enter in negative 1,000,000 or positive 1,000,000. And we need to reduce that to a number between 0 and 25, because 0 and 25 will actually encapsulate all of the different possible shifts in the alphabet. 0 is basically no shift at all, and 25 is actually shifting forward so far that it's actually equivalent to shifting back once. So what we're going to do here is we're going to use an if statement. We're going to check if shift is negative, and we're going to do a different thing if it's negative to if it's positive. So if it's positive or 0, we're going to be in this else statement, but if it's negative, we're going to be in this if statement. So if it's negative, we need to set shift is equal to 26 plus shift modulus 26. Basically what's happening here is we take the shift. If it's negative, we modulus it by 26. So if it's, let's see, if it's 27, this will end up being, if it's negative 27, this will actually end up being negative 1. So it takes out as many 26s as it can. The modulus in C works a little bit different to other moduluses in that sometimes it can print out, like it can return a negative number. So in the case of negative 27, this will actually be negative 1. Then when we add 26 to it, we'll get positive 25, which is equivalent to a shift of negative 27. So that's good. One thing here is that we have a number here, 26, which has been repeated, and it has some meaning to it aside from just 26. It's the size of the alphabet. So I'm actually going to hash define that number. So let's do a hash define alphabet ALPHA bet size, and that's going to be equal to 26. So now instead of 26, when people see alphabet size, they'll know a little bit about what it means. And alphabet size. Good. For the else statement, this is where the shift is... oh, by the way, after this line of code, we're guaranteed that the shift is going to be between 0 and 25. Because this expression here is guaranteed to be... Well, first of all, the shift is definitely negative here, because of this if statement, this expression will guarantee that the result of it is between negative 25 and 0, and then adding 26 to that will guarantee that it's between 0 and 25. Okay. So now we need to just handle the positive case. So if it's positive, we just need to have shift is equal to shift modulus 26. And so then this will also reduce it down to a value between 0 and 25. Okay, so that makes programming a little bit simpler for us later on, because we've now got an equivalent shift value. If the user enters in a very large shift or a very negative shift, we have an equivalent shift value which is smaller, easier to work with, which will output the same result. Okay, now we want to do a similar program to what we did in the deval program. We want to have a while loop which will take in a character and print out a character repetitively. So we want to first take in read in the initial character. So I'm going to say int character is equal to getChar. Remembering that we're using an int here because getChar can sometimes return EOF, which isn't a char. Okay, we're going to set up a while loop here. And we're going to do the same thing that we did in deval. We're just going to put char the character. And we're going to also reassign the value of character for the next iteration of the loop. Perfect. This condition here is going to keep looping through. It's going to cause the while loop to keep looping through until character is equal to end of file. So it's while character is not equal to end of file, we loop through. Good. So this is good so far, except before printing this character, we want to change it to the shifted character. So we want to say something like, okay, this is a little bit of a complex piece of the code, so I'm going to make it into a function to modularize our code a little bit. So I'm going to say character, I'm going to reassign the value of character, and it's going to be equal to shift letter, which is a function that we're going to make, and I'm going to give it character and shift. And so shift letter will take in the character and the shift, and it will output the character, which is the new character once it's been shifted along in the alphabet. Then we can print out that character and scan in a new one. Okay, so now we just need to make this function. So this is going to return a character. It's called shift letter. Shift letter. And it's going to take in a character and a shift. Perfect. So, in this function, we're going to want to shift the character repetitively. It's something that we're going to do, repetitively, which is why we're going to use a little loop to do it. So I'm going to set up an iteration, an I variable for our loop, and then I'm going to write, loop through, so we're going to loop through shift times shifting the character once each time. Great. So our while loop is going to, let me just get me a little bit of space. Our while loop is going to look a little bit like this. So our ending condition is when I is equal to, we're going to keep looping through when while I is less than shift. And then in each loop iteration, we're going to increment I using I++. Great. So this while loop will essentially run shift many times, and we just need to reassign the character. So character is equal to shift1 character. And I've decided to make a new function called shift1, so we're just going to make that now. Basically what it's going to do is it's going to take in a character, and it will return the character that's next in the alphabet. And if it's a Z, it'll wrap back to an A. Okay, the last thing we need to do is just return character. One important thing to consider here is what happens when shift is 0. If shift is 0, this while loop will never execute. So we can consider this code kind of to not be here. It doesn't have any effect if shift is 0. So when shift is 0, we just return character, which is good because that's exactly what we want to do. If we shift a character 0 times, we just return itself. Okay, one thing I want to do is make a little comment above this function which explains what it does. So something like shift letter shifts a character. You can say something like int shift many times along the alphabet. Cool. Okay. Now I've just realized that this function here, our shifting of our character, we're only going to want to do that if the character is an alphabetic character. So we're going to actually surround this in an if statement. I'll do this in a little bit. But we're going to surround this in an if statement so that if it's a space or if it's like an enter or a dot, it doesn't get shifted. So now let's create our function shift1 that we're calling here. So let's create the header comment for it. Shift1 basically shifts a character along the alphabet once. Perfect. So this function is going to return a character. It's going to be called shift1, and it's going to take in just a character, char character. And basically what we're going to do here is first test if it's a Z, because if it's a Z, we need to return A. But then if it's not a Z, we want to just add 1 to it and return that. So I'm going to create a variable called char shifted character. And this is going to be initialized using the following if statement. So if character is equal to lowercase z, then let me just space this out correctly. So then we want to set shifted character, which is what we're going to return, equal to lowercase a. So that will wrap around the alphabet then. And then if it isn't that, but it's equal to, if character is equal to uppercase Z, then we also want to shift that along the alphabet, except we're not going to return a lowercase a, it's going to be an uppercase a. Okay. Finally, else, we need a catch-all, so if it's anything that's a letter but not a Z, then we want to return that letter plus 1. So shifted character is equal to character plus 1. Okay, and then once we finish this if statement, we're guaranteed that shifted character has been initialized in one of these pieces of code. So now we can just return shifted character. Fantastic. So now we've got that function finished, we just need to create function prototypes for those two, because we're calling shift letter before the program sees what it is. So I'm going to create a little function prototype for it, just above the main function. I'll get rid of this line of code. And then I'm going to create a function prototype for the shift1 as well, just so we don't get any errors when we compile. The other thing I need to do, the final thing I need to do, is finish off this if statement. So basically, we only want to call this shift letter function. We only want to shift the letter if it's an alphabetical letter. If it's a space or anything else, we don't shift it. So I'm going to make a function called isAlphabetic. If I can spell it, alphabetic. IsAlphabetic character. So we'll send this function isAlphabetic character, and it will return either true or false, which is 0 or 1. And it will then execute this line of code if the character exists in the alphabet. So let's make that function. Int is alphabetic, and we're going to take in a single character. So, seeing as the alphabet exists as a contiguous sequence in the ASCII series, we can just use if statements to test if it's greater than A or less than Z. So if character is greater than or equal to A, and it's less than or equal to Z, then in this case it's a lowercase alphabetic character. So we're going to say result is equal to 1, and I'll create that variable int result. What we can do here is we can actually assume that result is equal to 0. In other words, it's not an alphabetic character. And then we can just set result equal to 1 if it is an alphabetic character. So, and then we just need to deal with uppercase characters. So if it's greater than or equal to uppercase A, and character is less than or equal to uppercase Z, then we just need to set result equal to 1. Great. Finally, we just need to return result. And I'm just going to add a little comment above this function explaining what it does. So is alphabetic, takes in a single character, returns 1 if it is alphabetic. So A to Z, A to Z, and returns 0 otherwise. Cool. So this should work. We just need to add a function prototype for it. So I'll copy this and paste it above the main function. Okay, fantastic. Let's save it and compile. So dcc-o Caesar, Caesar.c. We're not getting any compile errors, which is a miracle. Let's type Caesar. Oh, okay, so we need a command line argument 10. Okay, now we can test it by typing in part of the alphabet, A, B, C, D, E, F, G, H, I, J, K, and let's press enter. Okay, so A is being mapped to K, and then it's gone on from there, which looks right. A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, good. So we've gotten to K, which is the 10th character along. And this will keep actually working until we press Control D. We can type /Caesar minus 1000, and then we can do A, B, C, D, E, F, and that maps to later on in the alphabet.